Hi, I'm Professor Goins. In this video, I want to look at a technique or a procedure that comes up numerous times in Calc 2 and then also in differential equations. So in Calc 2, you'll see this when you are working with geometric series, when you're working with power series, Taylor series, things like that. You'll also see it in your differential equations course when you are solving differential equations using power series technique. The technique consists of the following. Suppose I have an infinite series of this form. So the sum n equals 1 to infinity of an expression. As a reminder, written out, it's these terms right here where I plug in 1, evaluate, add, plug in 2, evaluate, so on and so forth. So it's this expression right here. But suppose for whatever reason I wanted the series to start at 0. So the way I do that is as follows. So for one, I want the series to start at 0, so I'm changing my initial index value from 1 to 0. I still have to have the series to be the exact same though. So the question is, how do I manipulate this expression so that I can change the initial value yet keep this the same? So what I'm going to do is I'm going to look at this expression right here and I say, okay, well if I was to plug 0 in first, how do I get 1 over 2 to the first? If I plug in, so this is what I would get when I plug in n equal to 0. This is what I get when I plug in n equal to 1, n equal to 2, so on and so forth. And then we observe the pattern. So notice the value that I'm plugging in is 1 less than the exponent. So that means that the expression that I'm plugging into is the following. 1 over 2 to the n plus 1. If the number I'm plugging in is 1 less than the exponent, then that means that the exponent have to be n plus 1, right? So if I plug in 0, I get a 1. 1, I get a 2, so on and so forth. So if I want to change it from 1 to 0, I replace n with n plus 1. Okay. We'll summarize this all in the end, but let's go to this next example. Suppose now I wanted my series to start at 4. And I still want to have the exact same series, 1 over 2 to the first plus 1 over 2 to the second, etc. So what's the pattern? Well, this is when I plug in n equal to 4. This is when I plug in n equal to 5, so on and so forth. So we can see that the only thing that's changing, of course, is the exponent. So let's just start by putting in 1 over 2, and we have to figure out what the exponent is. So if I plug in 4, I get a 1. Plug in a 5, I get a 2. So think for a second of what this exponent would then be. Okay, so if you guessed n minus 3, then you'd be correct. So notice if I plug in 4 to n minus 3, 4 minus 3 is 1. 5 minus 3 is 2, so on and so forth. So let's summarize what we just found. If initial index value is 1, if I decrease it to 0, then I increased the index variable. If I go from 1 to 4, so I increase the initial index, I decrease the index variable. So let's write this as the following summary. Let's say I have the following. The sum from, n equals 1 to infinity of an. Let's say I want to increase this. So I go the sum from n equals k plus 1. To infinity. So I increase my starting value by k. So what that means is I'm going to go to my index variable and I'll decrease it by k. So that'd be n minus k. So notice that you'll put this off to the side here. Index increased by k. Let me be more specific there. the initial index increased by k, so therefore the index variable decreased by k. They go in opposite directions. All right, similarly, let's say I've got the sum from n is 1 to infinity of a sub n, and suppose I want to decrease this. So let's say I wanted to say this is the sum from n equals, let's say, 1 minus L to infinity. So I take the initial index and I decrease it by an amount L. That means I'm going to increase the variable by L. So decrease by L, increase by L. Increase by K, decrease by K. So they go in opposite directions. So again, let's summarize what happened here. The initial index decreased by L, so therefore the index variable increased by L. So let's look at some specific series and do some shifting. So let's take a look at this infinite series right here, 4 to the n over n plus 1 factorial. And I want to shift it so that the series starts with the indicated integer. Okay, so if I want it to start with n equal to 4, meaning I'm going to take the initial index value and I'm going to increase it. And again, if I look at my summary over there, we see that in purple, so that's the one on the top, the initial index goes up, so the index variable has to go in the opposite direction by the same amount, so it's going to go down by 4. So that means both of those n's in the expression are going to decrease by 4, meaning we would have 4 to the n minus 4 over n minus 3 factorial. Part B. So I want the initial index to be -1. So I want the series to start with -1, so -1 to infinity. And so again, this is less than the index value we started with, which was 0. So therefore, to convert to this one, the index variable has to go down. So the index variable has to go in the opposite direction by the same amount, so it has to go up. So therefore, this would be 4 to the n plus 1 over n plus 2 factorial. Okay. So just remember that these always go in opposite directions. If I'm going to increase the index, I decrease the variable. If I decrease the index, I increase the variable, and they always have to change by the same amount.